Hello class, it's Mr. Ng. Some of you were talking about how you were a little confused with tonight's homework, so I'd figure I would just kind of go ahead and do two of those problems for you so that you'll be prepped when I see you again tomorrow. So this is the first problem from your homework set. How many moles of gas does it take to occupy 120 liters at a pressure of 2.3 atmospheres and a temperature of 340 K? Okay, so the first thing that we gotta recognize is that this is in atmospheres, and if you remember in class, we have two R's to use. Sometimes we use the R 8.31 uh, kilopascals times liters over kelvins times moles, or sometimes we might use 0.082 ATM liters over kelvins times moles. You see, so I think what happened was a lot of us used the 8.31 in class, but the homework problem is in ATM, so some of us aren't using the 0.082. But for these next two problems, they're going to be in atmosphere, so we're going to use the R that is 0.082. So let's start with our equation. The ideal gas law is PV is equal to NRT. And I like making it nice and neat along the edge here. So PV NRT. Let's go through the word problem to try to identify all of these variables. Our first number here is 120 liters. That's the volume, right? Because it's in liters. So let's put that here. And then we got 2.3 atmospheres over here. That's obviously the pressure. 2.3 ATMs. And then a temperature of 340 kelvins. And then the N, we don't know. That's what it's asking for, how many moles. And finally the R, we know the R, it's 0.082 ATM times liters over Kelvin moles. Good. Part 2. So this is probably the hardest part, just kind of identifying it. Part 2 is just solving. So we need to solve for N. If I wanted to isolate N, I would probably divide both sides by RT. Right? That seems to be the thing to do there. So that means N is equal to PV over RT. Now all I got to do is plug in, right? So I know that P is 2.3 ATMs, atmospheres. I know V is 120 liters. I'm going to divide that by our constant, which is 0.082. Notice what I'm going to do here. I'm going to write down all the units. ATMs times liters divided by kelvins times moles. And then I'm going to multiply that by 340 kelvins. And check this out. Look, kelvins is on the bottom. Kelvins is on the top. They cancel. Right? Liters will cancel. ATMs will cancel, leaving the only variable, which is moles, which is exactly what we want. We wanted moles, right? So we know we're on the right track. We set this up appropriately. So I'm going to do 2.3 times 120 divided by 0.082 divided by 340 again, and I get 9.90 moles. Good, right? If you didn't get that from your calculator, you might be doing a thing where you divide by 0.82 and then you multiply it by 340. That's what I see a lot of what's happening. So just divide twice, because 340 is on the bottom, so divide twice. Or if you want to just punch it into your calculator with parentheses on both the numerator and the denominator, that might kind of circumvent that mistake. Let's try one more problem. So this is problem number 2. I have a 50-liter container that holds 45 moles of gas at a temperature of 200 Celsius. What is the pressure inside the container? Again, PV is equal to NRT. And I like to put it along the side. PV NRT. 50-liter container, that's our volume. 50 liters, right? 45 moles of gas, that's our N, 45 moles. at a temperature of 200 degrees Celsius. 200 degrees Celsius. Let's just convert it to kelvins now. Plus 273 is 473 kelvins, right? Oh, I think we all know that we need to convert to kelvins. And then it wants to know the pressure. So question mark on the pressure. And R, well, we're using ATMs, right? What was for the temperature? Yeah, well, the answer is in ATMs, another answer key. So let's use the 0.082 ATM times liters over Kelvin moles. Fine. So let's rearrange this equation. We want P. So to find P, I will probably divide both sides by V. These cancel. Pressure is equal to N RT divided by volume. Right? So N we know is 45 moles. R is 0.082 ATM liters over Kelvin moles times our temperature, which is 473 kelvins, divided by our volume, which is 50 liters. Look, some magic's going to happen again. These units cancel, liters cancel, moles cancel, kelvins cancel. So we are stuck in ATMs, and that is what we want. We want pressures in atmosphere. So I'm going to punch through the math. 45 times 0.082 times 473 divided by 50, and I get 34.9 ATM. I want to draw myself a happy face because I did it right. I am smart. So I hope that helps. So I think the biggest thing, the biggest takeaway is maybe you guys are using the wrong R. Again, the R that we should be using is 0.082. Just for this homework assignment, just because we're using ATMs in this homework assignment. And maybe some of you are kind of punching it into the calculator wrong, so make sure you do that nice and slow. Thank you very much for watching, and I will see you guys tomorrow.